Hey John, I'm going to demo some of the first part of this NAND2Tetris project where you implement the logic gates from a NAND and then test them in the hardware simulator. So I got the project here. It's broken into essentially the modules with the different projects and then the tools directories where they have all the different simulators where you can test the stuff and run it. So I'll go to projects. Project zero is just kind of an intro thing. There's nothing really there. Project one is where they've got all the logic gates that you have to implement using just a NAND gate, the universal gate, logic gate. And so you can see they have NAND and so on. They have single bit and they have 16-bit implementations for these. And so I'll just do not and or here, and this is what the file looks like. And then I'll look at the truth tables for these. So we're given a NAND. We're going to use a NAND to build everything. NAND is just it's just a NAND, an AND gate inverted. Of course, we know what an AND gate does. That just is zero unless A and B are both one. In that case, it's a one. So a NAND is the logic flipped for that. So when both are zero, it's one. In all other cases, it's zero. So it's going to be really easy to make an AND, of course. We'll just take a NAND and then invert it. So the inverter, the NOT gate, is just obviously just flips the bit. But it's a unary operator, only takes one input, but the NAND takes two. So we're going to have to pass in another input. We don't have one in this case, so we'll just have to put in A for both. In other words, these two parts, these two rows in the truth table can be kind of ignored here for the NOT gate. It's where both inputs are the same, and indeed, when it's zero, it flips it to a one, and when it's a one, it flips it to a zero. So uh, basically, just send in the same input for both inputs to the same value for both inputs into a NAND. That'll invert the value. I've got a logic gate circuit simulator here called Logisim that I use. Um, and so we can see those here where here's the basic not the basic NAND gate. When they're both zero, it's one. Excuse me. Yeah. When they're both zero, it's one. When either or are one, it's one, and only when they're both one is it zero. So here's the not. If we take one input and feed it into both one value, feed it into both inputs of the NAND, it flips the logic. And so if we just take a NAND and then take its output and feed it into an inverter like here, we will get an AND. So when they're both zero or either or is one, it's zero, and only when they're both one is it one. So we can we can implement that here. I'll go to the not first, and the one thing we have here is the NAND, and the syntax for this, I looked it up. It's kind of like they're just like functions, and you have to define what these are going to be. So um, the syntax for the NAND is always A, B, and out. So we basically just define it like this. So A is going to be in the these are like the variables declared, the inputs and outputs declared, and then the parts are the implementation. So A and B are both in, and out is just out. Save that, and then I'll open up I'll come back over here to the tools um, directory and open this in the terminal, and I'll just do ls and do /hardware simulator .sh and run it. It's a Java project, so as long as you have the Java runtime installed and everything, you can just kind of run it. For me, I'm on Linux, so it's these script .sh files. On Windows, they'd be the bat files. But so here's the simulator, and basically you just click on this to load a chip, and so I'll find my NOT here, and I'll load this. And you can manually test it. You can manually kind of poke values, and like this, we could hit that, and the input's 1, and then you could hit this button to evaluate, and it would do that. But they also provide in this directory, in the projects directory, they provide a bunch of test scripts as well. So that's the .tst files, and you can load that with this. So I'll just load the not.tst, and then I'll hit, I think it's this one, run, and it just kind of runs through its test script, and then yeah, it ended successfully. So so that's the not. I'll do the and here. I could use this not in here if I wanted to, but I'm gonna do everything. In other words, you can, if you when you implement one, you can use it in another file. But I'm just gonna do everything with NANDs because that's what they want you to do. So I will. I'll do NAND A is equal to A, B is equal to B, and out is equal to, I'll call this, just X or something. That's like my intermediate variable. You don't need to declare it here. You can just declare it in line. So now the output of this NAND is in a variable called X, and then I'll just now invert this. NAND A is equal to X, B is equal to X, whoops, and out out is equal to out. So I'm basically taking these in, putting it through the NAND, storing it in X, then putting the X in both of these ones, and then sending that out. So we'll go ahead back to the simulator, and we'll load the AND chip. Here it is. And then we'll load the test script for AND, and we'll run it. Okay, that was successful. The next one is the OR, and the OR is a little bit more to do there. We can use this law in Boolean logic called De Morgan's law. You may have heard of this, but basically it's just if you've got you can if you not any either and or, it's the same as knotting each individual thing and flipping the sign. So if you have not A and B, that's equal to not A or not B. And it goes the other way too. Not A and not B is equal to not A or B. So it's kind of like it's like mathematics where you uh, would distribute this not and then flip the sign. So using this fact, we can look at this line in particular. We know that we've got this A or B. That's where we're trying to get to. We know we have and already, and we have nots. So we can basically we can implement this, and that'll give us this. But then we can wrap this in a not so that we can kind of undo that. So in other words, not A, or excuse me, not A and not B. If you did that, that would be equivalent to A or B. So I'll do that first in this Logisim program. Um, if we take a NAND gate for each A and B, and we'll do these, put these inputs here like this. So these are going to be the not A and not B. We'll wire them up like this. So that's not A and not B. And then what are we going to do next? We're going to, we've got these two now. Now we're going to just AND those. Well, we know that an AND is a NAND where you invert its, whoops, you invert its output. So we can take another NAND gate here. Whoops. Take a NAND gate, and we'll need another NAND gate right after that. And then we can just wire this up this way. And then we're going to invert that right away into another NAND. And and then what are we going to do? Oops. We're going to invert the whole thing again. So we're going to invert the whole thing all over again. And let's test that. So we're going for an OR. So they're both 0, it's 0. We go a 1, we got a 1, we got a 1 here, we got a 1. And then if they're both 1s, we get a 1. So that's the OR. But we can see here that we have two inversions in series, one after the other. So that's pretty much not necessary, right? We're flipping the logic, then we're flipping it again. So we can just get rid of this stuff here altogether. And that's going to be the same. Let's test that. They're both 0 at 0, 1, 1. And if they're both 1s, it's 1. So we'll basically we'll make two inverters and then pass those into a NAND, and that's going to be an OR. So we'll do that real quick for our OR, and we'll test it, and we'll be done. So we'll take a NAND, and so this is going to be A is equal to A, and B is equal to A, and out is equal to X, just like before. But now this one is going to be A is equal to B. We'll send B into this one. B is equal to B. And out, I'll just call this one Y. And then our final NAND, we'll take that one and we'll say A is equal to X, B is equal to Y, and out is equal to out. So pretty basic syntax for this HDL, high level description or hardware description language it's called. So we'll just bring back the simulator and we'll load the OR and we'll load the test script and we'll test it. And that's it. It was successful. I won't show all the rest of the gates, but if I make any more progress on some of the rest of this thing, um, some of these modules, these subsequent modules, maybe I'll make some videos when some interesting stuff happens. Talk to you later. Bye.